Hi guys, and welcome back. So in this video I'm going to show you guys how to find out the rule of a quadratic when you're given a graph. Now this is a really important thing to know how to do. There's a few ways you can do it. So in this series of videos there's going to be a few different versions of this. There's going to be ones where you're given the turning point, there's ones where you're given the roots, some where you're just given coordinates, stuff like that, so that will help you out. So I'm going to show you how to do those things. You can see in the learning objectives at the top here, these are the things that we're going to try do. Okay, so we've got how to find our answer in root form, in turning point form, and then also when you're given information such as roots and points on the graph. Okay, so that's what we're going to try and do for the next few videos. Okay, so here's my example here. I've got a graph and to find the quadratic from the following graph. So let's have a note on what important things I'm given. So I'm given some important points here. I'm given this point and this point, which are our roots, or also known as x-intercepts. So in this case, I've given the coordinate -1, 0, and 3, 0. I'm also given an important point up here. So this point right here, that's my y-intercept here. Okay, so I'm just going to write those coordinates. And I like to do this the first thing I do when I see a graph. I'm almost guaranteed to always be given at least two kind of important features to help me find the rule from the graph, okay? Now, if you're given the two roots, the easiest thing to do is to find the quadratic in a root form. So if we recall, root form, so these letters B and C represent what the intercepts are, so our x-intercepts, because for most quadratics you're going to have two roots. Of course, we are aware that there are some graphs, for example, that look like this, where they don't have any roots, and there are some graphs where they just touch the x-axis, and that's only one root. But for these examples, as you can see, like the one on the screen, we've got two roots, so we're going to use this form here. Okay, so what I'm going to do is I'm going to substitute these points here, -1 and 3, into this here. Now we can note that there are negative signs here. That's the general format. So when we have a -1, we've got to make sure that we change that to a plus. So let's rewrite that. So remembering that's a scale factor, by the way. That's how wide our graph's going to be, and we're going to work that out in a second. So my first bit's going to be +1, because if you think about it, it's going to look like that. And those two things are going to make a plus, right? And then we're going to have our x take 3, okay? So that's my first piece of information kind of sorted. Now, I need to find this a, because I can't just assume that my a is going to equal 1 or there is no dilation or scale factor. So I'm going to actually work out my a and just double check by substituting a coordinate in. Now, I'm going to substitute the y-intercept in, because that's why they've kind of given that to us. So let's do that right now. So I'm going to go and sub 0, 3. So I'm going to write in here, so 3 is equal to a, so 0 plus 1 is 1, 0 take 3 is -3, so 3 is equal to -3a, so of course a equals -1, because I've just divided 3 by -3. So that means y is equal to x plus 1, x take 3. And we know that that should be a negative because we can see that's a maximum, isn't it? So because we can visually see it's a maximum, or like a upside down graph, that's how we know it should be a negative, and that's what we found out, so we're on the right track.